Welcome back, Mr. Wakefield here. We're looking at the second half of section 9.5. We've already done the first half. And so we're going to turn to the second page of this particular section and finish things off here in this section 9.5. If you look at these 5 problems here on the second page, which is what we still have left in this section, you'll notice there's something in common here that was different than the problems we did in the first half of this section. In all 5 of these problems here, you'll see that on the bottom there's 2 terms instead of 1. And again, that means that you have 2 terms separated by either a plus or, as in the case of this problem, a minus. Remember, pluses and minuses separate into different terms. Radical terms are no exception with that. And so because it's 2 terms, we've got to handle it differently. And let me tell you why. Okay, do not write down what I'm about to write down, because I'm eventually going to erase it due to the fact that it's not going to work. But just to show you that this is not going to work, because I know some of you might be thinking this, you look at the square root of 3 and you think, oh, hey, let's multiply that by the square root of 3. Okay, the problem with that, as we learned back in chapter 7 when we were doing fractions, if you multiply something by a denominator or numerator, in this case the denominator, you have to multiply by the entire denominator. So if that denominator has more than one term in it, you've got to bracket it and then distribute. Okay? The problem with that is that if you multiply square root of 3 times square root of 3, yes, that's what you want it to be. That's equal to square root of 9. That's going to end up being equal to 3. The radical goes away. Oh, hey, that's wonderful, right? Well, there's a problem, though. The problem is that when you distribute the other part, you get 1 times square root of 3, and so you end up with this right here. When you distribute, you get these 2 terms here. So this one becomes 3, and the radical goes away. That's great, but then there's a radical over here that you can't get rid of. And so that's my point, okay? It looks like you can get rid of the radical, but then it pops back up here in the second part of the distribution that you did, the second multiplication. And so that's not going to work. So let's go ahead and erase that. Okay, let's erase that off. What's the right way to do it? The right way to do it is by using this formula that we saw back in chapter 7, section 7.4 when we were factoring. Okay, we had the a squared minus b squared formula, and it was equal to this. All right, we're going to use that here, but not to factor, but instead to multiply. Okay, because look at the first problem here, and I've listed out all 5 of the denominators in the 5 problems that we're doing here. All 5 of them, okay? But let's start out with the first one. The first one is square root of 3 plus 1. I put it right here. That matches up with a plus b right here. If I multiply that by a minus b, now what would a minus b be equal to, first of all, before I multiply it? If a plus b is this, then a minus b, wouldn't it be this right here? In other words, it would be the same thing, except for the sign in front of the second term changes. So for plus, you'd if it's plus that you started with, then you'd multiply by the one that has minus in front of the second term. Okay. So a plus b is this plus 1, square root of 3 plus 1. So this must be square root of 3 minus 1. Again, same terms, but the sign in front of the second term changes. Okay, why do I want to multiply these 2 brackets together? Okay, and let me go and write that down, by the way. So I'm going to multiply by this. And you'll see why in a second, why this works. But that's what you want to multiply by. Okay, and since this has 2 terms, I'm going to bracket it so I can multiply it. Well, we know that when we have a minus b times a plus b, it's equal to this. Okay. What is the a and the b in this particular problem right here, though? The a is the square root of 3, isn't it? We can see that because you can see a is square root of 3, a is square root of 3. Okay, so therefore, when we say a squared, we're squaring square root of 3. I'll get to that in a minute. And then you can clearly see here as well that 1 is b. You see 1 is b here, 1 is b here. All right, so we're squaring the 1. The minus, by the way, is part of the formula. That's separate. So it's not -1. It's just 1 that's equal to b there. Okay. And then the minus goes down between that in the formula there. Is this going to get rid of the radical, though? It sure is. Let's find out why. Okay. According to order of operations, and since there's no variables here, I'm going to do order of operations. We do exponents before subtraction. Okay. So if I do the exponents, what happens when you square a square root? Okay, we haven't really seen that before, but if you think about it, when you square a square root, as long as it's not one of those square roots that has a negative on the inside and there's not really an answer there. Otherwise, when you square a square root, it's equal to, and I'll prove it to you here, as you guys know, when you square a square root, you're multiplying, or anytime you square something, you're multiplying that thing twice, aren't you? When I square the square root, I'm multiplying the square root twice. Okay? So we know how to multiply this now. Inside times inside stays inside, but then if I calculate the radical, I get what? I get 3. It's not a coincidence, you guys, that it's equal to the number on the inside. Okay, if you square a square root, no number on the outside of the square root, but there's just a radical only, and that's a square root radical. If you take that radical and you square it, it will always be equal to the number on the inside every time, as long as it's not a negative. Because if there was a negative on the inside, then that would be like squaring a number that doesn't exist. Okay, and you can't do that, so there wouldn't be an answer in that case. But as long as this number underneath the square root radical is not negative, then whenever you square a square root, it's just equal to that number underneath the radical. In other words, the square root radical symbol and the exponent basically cancel each other out, and it just becomes the 3 by itself. Okay. And then 1 squared is 1, and so I squared that. So now I subtract after I do the 2 exponents. Again, exponents come before subtraction. And our denominator ends up just being equal to 2. Okay? So in other words, if I multiply these two things together, and I know they're in a different order than these two brackets, but that doesn't matter, because when you're multiplying together 2 brackets, you can reverse them, and it's still going to be the same answer, 2. Okay? Because when you multiply 2 things, you can reverse the 2 things being multiplied, and it'll still give you the same answer. Okay, that's how multiplication works, even with brackets, like we've seen before. Okay, so that means, and I'll go ahead and just rewrite my work here so I'll have it on the page. It's equal to this. We do exponents before subtraction. And then it ends up being what? Then it ends up being 2. I'm going to make the denominator a little bit, or the fraction bar a little bit bigger than normal. You'll see why here in a second. But the 2 goes in the bottom. All right. Now, as we did in the first part of section 9.1, we need to multiply the top by the same thing that we multiply the bottom by. But how do we multiply a single term by a bracket with 2 terms in it? We distribute. Just like we did at the first day of class when we learned when we had a single term multiplied by a bracket like that with 2 terms in it. Okay. What is square root of 6 times square root of 3? We just learned about how to do that, right? Okay. We learned about how to multiply radical terms together. Square root of 6 times square root of 3. If there's nothing in front of either radical, okay, then you just multiply inside times inside equal to inside. Same thing here. Square root of 6 times square root of 3 is square root of 18, isn't it? Don't need to do anything with the outside because I'm sorry. There it is. My fault. So there's nothing on the outsides there, so we just do inside times inside equal to inside. Okay. And we get square root of 18. And then what about square root of 6 times -1? Well, anytime you multiply something by -1, it's equal to itself, but it changes the sign because of the negative. So it's going to so the square root of 6 becomes negative square root of 6. Okay. You still do the same thing that you did in the past when you distributed. You always put a plus or minus in between your answers, just like you did then. you got to still do that now. Just don't put the negative or plus in front inside the radical. It's got to be in front of the term, okay, in between the terms. And so that's basically the answer there, other than the fact that, and again, just like before, once you get rid of the radical in the denominator and you end up with just a regular monomial term, no radical, then you're basically done, as long as you also do that one additional thing that's mandatory, which is to check to make sure your radicals are simplified in the answer. And as it turns out, the rad 18 could be simplified, or can be simplified. It ends up being 9 and 2, which after we compute that first radical right there, it's going to be 3 rad 2, isn't it? So yes, after you make the denominator what it's supposed to be, you simplify your radicals, okay? And we get this right here. Now, can I subtract these two radical terms? As I learned in section 9.3, I cannot subtract these because you cannot subtract or add two radical terms unless they have the same radical, right? Okay, that's what we learned in 9.3, a little bit of review there. Okay, since we're subtracting, these two terms cannot combine unless the radicals are the same, and they're not. And I cannot simplify them to make them the same because these two radicals already are simplified as much as they can be simplified. Okay, you can't simplify them anymore. And so that's the answer. So I made the denominator so that it doesn't have a radical in it. It's just a single monomial term like normal. And then I simplified any radicals I had left. The 6 was already simplified. The 18 I took care of right here. And we're done. Let's try that again now. Okay. Problem H. This time we have square root of 2 plus 1. Square root of 2 plus 1, you can see I wrote it here, and I wrote it on the second part here again because it matches up with a plus b due to the fact that there's a plus in between here. So what do I need to multiply by? Well, if you're doing a plus b to start, then that means you got to multiply by a minus b. Okay, that means that it's the same two terms, but you change the sign of the term that is in front of the second term. I'm sorry, you change the sign of what's in front of the second term there. So the plus becomes a minus over here. Okay, and then you multiply these two things together. What do we get? According to the formula, you are supposed to square each term. So I square the square root of 2. That's the a, and that's why it says a squared here. We square that. And then the b here, as you can see, the b is the 1 again. So we're going to square that. That's the b squared part here. And then the minus falls in between that. What do we end up with here? If I do my exponents first, as we just learned a few minutes ago, if you square a square root, it's equal to the inside. The square root symbol and the exponent cancel each other out, as long as the exponent is 2 and it's a square root. Okay, if you were cubing it, okay, if you were taking it to the third power, that'd be different. Okay, it doesn't cancel in that case. But a square root and an exponent 2, they cancel. 1 squared again is 1. And then if I subtract, the answer is 1. So that means that my brand new denominator, you guys, my brand new denominator is going to be equal to 1. Let's just rewrite that out now, okay, on the paper, if you haven't done that already. All right, like that. We now know, according to what I just wrote down on the separate sheet of paper, we now know. And you don't have to write this down on a separate sheet of paper. You can put it on your own paper since I'm transferring it over anyway. I just put it on the separate sheet of paper so you can see how all of them tie into each other here, how they're all related to each other. It just makes it easier to learn that way, I think. So, but you don't need to write this on a separate sheet. As long as you have it here, that's fine. Okay, so the denominator ended up being 1, right? Because this is 2 minus 1. And then there it goes right there. Now the numerator is going to be a lot bigger this time. Okay. Should probably make a little bit more room, in fact. Okay. All right. Then we got what here? We got these two terms. Since there's two terms here separated by the plus makes it two terms instead of one. Again, if you have more than one term in your numerator, you got to bracket that, just like with the denominator. You got to bracket that when there's two terms down here because you're multiplying it by something. So if I got a bracket here with two terms and I got a bracket here with two terms, okay, what does that remind you of? Let me help you out here if it's not coming to you here, okay? What that should remind you of is, again, back on the first day of class, if you've got two terms in each bracket and you're multiplying, okay, again, the pluses and minus break it up into two terms in each bracket. Then you are doing the thing where you multiply the first term by each of these terms, and then you multiply the second term in the first bracket by each of these terms as well, and you end up with a total of 4 multiplications. Same thing here. You start out with the first term in the first bracket, multiply it through, and then you go to the second term in the first bracket, you multiply that by each one of the terms in the other bracket also, and you have a total of 4 multiplications. Let's do those 4 multiplications carefully here, okay? Because we're not used to doing it with radicals. We're still getting used to that right now, aren't we? 6 times rad 2. 6 times rad 2, that's just like 3 times rad 7. You got a regular term and then just a radical with nothing in front of it. So that's just, it just smashes together, smooshes together into 6 rad 2, nothing combines. Then you have 6 times negative 1, no radicals there, so you just multiply it the way you normally would. 6 times negative 1 is negative 6. And remember, just like when we did these problems before with the two terms in each bracket, you got to put pluses and minuses in between the answers. Thus, the minus there because it was negative 6. Okay? Square root of 2 times square root of 2. Okay, that's just like square root of 11 times square root of 5. Just two radicals, nothing in front of them. Multiply the inside parts. We get what? We get, and by the way, how do I know what the sign is? The sign that you put in front of the answer is determined by the outside of the radicals, not the inside. Okay, so since the outside of each radical term is positive here, positive times positive, it's going to be plus here. And we get what? Inside times inside gives me square root of 4. Yes, I can simplify that. I'll do that in the next step. And then finally, as we mentioned a few minutes ago, if you've got a term times negative 1, all that does is change the sign of this one right here when you multiply by negative 1. So square root of 2 becomes negative square root of 2. Again, the sign of the answer goes in front of the radical, okay? And each the two terms you're multiplying, and I say this because I don't want you to get it confused with the inside of the radical. When you're trying to figure out the sign of the answer when you're multiplying radical terms together, you look at the front of the term, not on the inside of the radical. So plus times minus is negative, and then you put that negative in the front of the answer, not inside the radical. Okay. So now I simplify my radical term just like I did over here. This is going to become what here? This is going to become a 2 right here, isn't it? I'll just write, instead of writing an entire extra step here, I'll just change it to 2 like that. One more thing we need to do, though. First of all, you can discard the 1 here. We know that when the denominator is equal to positive 1, you don't need to write it anymore. So you could, if you want, you could keep the 1 there, but you don't have to. But another thing I want you to realize is that notice after I simplify my radicals, make sure to simplify them first, you realize here that there's some terms that can be combined. And when you add and subtract a bunch of terms together, you can see that we have a couple of radical terms and a couple of regular terms after you change this to a 2 here. Negative 6 and 2 are just a couple of regular terms. The 2 radical terms are like terms, and the 2 regular terms, negative 6 and 2, they're like terms as well since they don't neither have a variable in it. And so you can combine those. So in other words, you guys, if you have a bunch of terms, a combination of radical terms and regular terms, all being added and subtracted together, okay, with pluses and minuses in between them. What you do is you try, and usually it doesn't work, but you try to combine the radical terms together and the regular terms together if they have pluses or minuses in between them with no brackets or anything. Okay, it's just like a normal polynomial where you try to combine like terms, kind of like this right here. You can see that we got a bunch of pluses or minuses in between the terms, no brackets anymore. Okay, that's the step where you oftentimes can combine like terms. No exception here. Okay, how can I combine these? Well, 6 rad 2 minus rad 2, minus 1 rad 2, in other words, is going to be 5 rad 2. And then negative 6 plus 2 is negative 4. Again, put pluses or minuses in between the answers when you combine like terms, like always. Since it was negative 4, I put a minus here. And again, you don't need to write the 1 underneath it. You can if you want. You don't have to. Okay, so let's review here. Again, you figure out what you're going to multiply by, like always. You're not normally going to have any radicals that simplify in these two-term problems on the bottom. But if you do, go ahead and do that first, like we did in the first half of 9.5. But then you figure out what you multiply by, determine what your denominator is. But then you got to multiply out the numerator. You can't just leave the brackets here. You have to multiply it out. That gives me this here. Then simplify your radicals just like we did in the first half of 9.5. Simplify your radicals. And then, very rare case here, but if there's some like terms that combine, do that as well. Usually there won't be, and usually the last step is just to simplify the radicals. Okay, but this was one exception here that we saw, where they did have some like terms. Okay, one more problem here before I ask you guys to try a couple. All right, what is going to be the thing that we multiply by here? Since it is square root of 5 minus square root of 7, let me bring that up here. Okay, move it over so you can see it. Square root of 5 minus square root of 7, according to the formula, that fits into the a minus b part. And so it must be what? It must be square root of 5 plus square root of 7 that you're supposed to multiply by, because it's supposed to be a minus b times a plus b. Okay? Let me go ahead and write that down. Okay, what is that going to end up being equal to? Let's take a look. According to the formula up here at the top, it's going to be square root of 5 squared minus square root of 7 squared. Again, exponents come before subtraction. And so we also said that a square root being squared, again with nothing, if there's something outside the radical here, that's different. You don't need to worry about that right now, though. But if there was something outside the radical, that'd be different. But if it's just a square root radical and it's a square, which means it's a second power, the radical and the 2 cancel each other out, and you just end up with 5 and 7. 5 minus 7 is negative 2. So that means that my brand new denominator is going to be negative 2. Okay? And so let's go ahead and I'm just going to, again, move this over here so that we have it on the paper. All right. Sorry, that's kind of tight right there. Let me zoom in there. There we go. Square root of 5 minus square root of 7, and that is, as we just found out, 5 minus 7, which is negative 2 is our brand new denominator. Again, our numerator is going to be kind of big, so that's why I made the fraction bar so large. Okay, like that. Yeah, the negative 2 goes down there. All right. We have to multiply the top by the same thing we multiplied the bottom by. Since that thing we're multiplying by has 2 terms, we bracketed it. But since the original numerator also has 2 terms in it because of the minus sign there, that means I need to bracket that as well. So once again, just like in the last problem, we have 2 terms in each bracket. and the brackets are being multiplied. That means what? Same as the last problem, we multiply 3 rad 6 by each of these two terms here. And then we also multiply negative square root of 2 times each one of these two terms here. Total of 4 multiplications again. Let's do it carefully here. 3 rad 6. 3 rad 6 minus or times rad 5. Okay, that looks like this one right here, where you got the 3 on the outside, but the other radical, the rad 5, doesn't have anything. And so you just do what? You do 3 times the invisible 1 here. 3 times 1, outside times outside stays outside. And then 6 times 5, inside times inside stays inside. Okay. And then 3 rad 6 times rad 7. Again, one of the radicals has a number on the outside of it, the 3, but this one does not have a number on the outside, so it's 3 times the invisible 1 right here. 3 times 1 is 3. And remember, that's positive times positive on the outside. And so that's going to make it positive 3. So I'm going to put the plus there. All right. And then inside times inside, 6 times 7 is 42. So 42 goes inside. Inside times inside goes inside. Then we have what? Then we have negative 1. There's an invisible 1 here. So negative 1 rad 2 times rad 5. Negative 1 times 1, outside times outside, is negative 1. So I put the minus because it's negative, and you could put the 1 here if you want, but because we're going to have a radical after that, the 1's not necessary. Okay? Like we've said before, if you have negative 1 times something, the 1 doesn't need to be written, but the minus does. So I have the minus here, but the 1 doesn't have to be written because we're going to have the radical part right after that being multiplied by it. So we have what? 2 times 5, inside times inside stays inside like that. Minus rad 10. And then again, negative 1 times 1, outside times outside that's negative 1. So we put the negative. You could put the 1 if you want, but you don't have to because it's going to be multiplied by something here. Square root of 2 times square root of 7. Inside times inside stays inside, like that. Okay? I just need to get this out of the way. Hold on. I was going to show you something here. This is, since all of those radicals, you guys, are already simplified, none of these simplify, and because there's no like terms to combine, this is essentially done, this problem. But there is an optional thing that you can do. Again, if you want to make your answers look like the back of the book, you don't have to, but I recommend that you check your answers in the back of the book. So for that reason, you could. They like in the back of the book, they like to have their denominators be positive if there's just a single term down there. And so to make it positive, you multiply the top and the bottom. You got to remember, if you multiply the bottom by something, you got to multiply the top by the same thing. But if I multiply the bottom by negative 1, it's going to make that positive 2, isn't it? So that'll get the job done, won't it? It'll make the bottom positive. All right. You just got to remember to multiply the top by the same thing. So that makes the bottom what? That makes the bottom 2. But when you multiply a term times a numerator that has a bunch of terms in it, again, separated by pluses and minuses, okay, you are multiplying by this entire thing right here. Okay, you got to put a bracket around that and then distribute the negative 1 to each thing. Okay, so that's what we're going to do. You distribute the negative 1 to each one of these 4 terms. Okay, but when you multiply a term times negative 1, all it does is change the sign in front of the term, not inside the radical, but in front of the term. So we get, instead of positive 3 rad 30, we get negative 3 rad 30, like that. Instead of positive 3 rad 42, we get negative 3 rad 42. Instead of negative rad 10, we get positive rad 10. Again, the sign changes in front of the term. And then instead of negative rad 14, we got positive rad 14, like that. So this is the way the book would give the answer. But if your answer was This up here, you guys, that's perfectly fine. If you had circled this answer right here, this big fraction right here, that's perfectly fine. I do not require you to have positive denominators. Only the book is asking you to do that. Okay, but I don't require it. So either one of these answers is fine. Okay. All right. So we have 2 more problems to go. Just to get you off to a good start here before I ask you to try this on your own. The first one here has rad 2 plus 2. So wouldn't that be rad 2 minus 2 that you're going to multiply by here? Okay, that's what you're going to multiply by, rad 2 minus 2. Please, you guys, don't forget that the sign changes there in front of the second term. A lot of students make the mistake of just multiplying by the same thing and not changing that to a minus. I think they do that because there's a lot of problems in the first half of 9.5 where you multiply by the same thing, especially in the square root problems. Okay, that's not what happens here. The sign changes in front of the second term. Okay, so I'll let you finish that one up. Remember, you got to multiply the top by the same thing. But yeah, I'll let you finish that problem up. Okay, and then in problem 8, you got square root of x minus square root of 3. So therefore, you got to multiply by square root of x plus square root of 3. Again, the sign in front of the second term changes. Otherwise, it is the same thing that you're multiplying by other than that. Okay, so you're going to multiply by square root of x plus square root of 3. Okay, which means you got to multiply the top by square root of x plus square root of 3 as well. Don't forget to bracket these things because they have more than one term in them, in both the numerator and denominator, and so that'll remind you that you got to, on the top anyway, you've got to multiply that out with 4 multiplications on top, just like we did in the last couple of problems. On the bottom, you just do the a squared minus b squared thing right here as a shortcut. You could do 4 multiplications on these problems, you guys, because it is 2 terms in each bracket, but this is a shortcut to that. It'll give you the same answer here if you do a squared minus b squared here, okay, instead of having to do the 4 multiplications. All right, so go ahead and try 7 and 8. Hit the play button after that, and then we'll wrap up this section with these last 2 problems. Okay, number 7. We already know we need to multiply by square root of 2 minus 2. Okay, if we go back to our formula sheet here for that, you can see that that comes out how? It comes out as square root of 2 squared, because the square root of 2 is the a part, all right, from the formula up here. And then the 2 without the radical, that is, the b part, that goes over here, b squared. So what do we get here? We get, again, when you square a square root, it's equal to the inside of the radical. But be careful here. Remember, there's no square root here. So you're just squaring 2 like you normally would, just like anytime you do 2 squared, and that would be 4, wouldn't it? So 2 minus 4 is negative 2. Same as the last problem, actually, here. Okay. And so I went ahead and transferred that over here onto the sheet. We ended up with 2 minus 4 equal to negative 2. Okay. And then when I multiplied out the top here, I did the 4 multiplications. 6 rad 2. Okay. 6 times negative 2 gave me the negative 12. Negative times positive gives me negative right here. And then 5 times 2 goes on the inside, rad 10. And then negative times negative is positive, so I put the plus right there. And then 2 times rad 5 just smushes together. Okay, there's nothing to combine there. Now that I've done the multiplications, okay, and I've got this set of terms here laid out here, I try to simplify my radicals, but they're all simplified already. 2, 10, and 5 do not simplify. And then just check to see if there's any like terms. There are none, because remember, radical terms are not like terms unless they have the same radical. And then you can never combine a regular term with a radical term when they're being added or subtracted, okay? Multiplied is different, okay? As we've already learned, you can multiply a regular term times a radical term, but you cannot add or subtract a regular term with a radical term, okay? Ever. You can't do that. And so this stays the way it is. You can circle this answer if you want, but you could also, in order to match it up with the book's answer, you can multiply the top and the bottom. Again, why do I do that on some problems but not others? It's when the denominator is negative that the book likes to do that. And so if we do that here, the bottom then becomes positive 2. And then when you multiply a numerator with more than one term in it by negative 1, it just, the negative 1 distributes to each term. And whenever you multiply by negative 1, as we mentioned before, that just means that the sign in front of each term changes. Okay, so instead of positive, negative, negative, positive, we now have negative, positive, positive, negative. All the signs changed. Otherwise, the rest of the term stays the same. And so that's your final answer right there, number 7. Number 8. As we already agreed from the sheet here, we need to multiply by square root of x plus square root of 3. All right, so that's what we'll do. Let's see how it comes out here first before I transfer it over. So I get what here? I get square root of x squared, because the square root of x is the a part, from the formula again here. Okay. And then the square root of 3 is the b part, so we get square root of 3 squared. What do we end up with here? Square root of x squared. Again, you're squaring a square root, so that's just going to be equal to the inside of the radical, which is x. And then same thing here, you're squaring a square root, so it's equal to the inside, which is 3. These are not like terms, so we have to stop right here. Okay, all these other ones were like terms, so we were able to subtract. You can't subtract x and 3 because they're not like terms. Yes, I know that we're normally supposed to have a single term on the bottom of our radical, or I'm sorry, of our fraction in this section when we rationalize the denominator. But it is okay actually to have 2 terms, just so long as there's no radical and just so long as they're both normal monomial terms. Okay. The important thing is we have no radical. All right, so if you get 2 terms separated by a plus or minus in between 2 regular monomial terms, that's fine too. That's rare, but it's okay. Usually it'll just be a single term though. Okay, like we've seen on all the other problems so far, up to now. So anyway, we end up with x minus 3, as you can see there. Again, there we go. And so on the top, how did I get that? Again, we have to multiply square root of x plus 3 by the top as well. So I did that here. 4 multiplications again, because each bracket has 2 terms in it. We end up with these 4 terms. This one does simplify because square root of x squared is just equal to x. All right. So again, after you do your multiplications on top, you simplify your radicals like we talked about. And then if there's any like terms to combine, you do that as well. There are no like terms here because 3 of the terms have radicals that do not match each other. And then there's a 4th term that doesn't have a radical at all, so that cannot combine with any of these other terms, because you can't take a term that doesn't have a radical and combine it with a term that does have a radical when the terms are all being added and subtracted together, which these are here with the pluses and minuses in between them. Okay. You might be wondering, what about the bottom here? Since there's a minus on the bottom, do we need to get rid of that to match it up with the textbook? No, you don't. Not when there's 2 terms. That's just when there's 1 term that they want you to do that. Okay. If there's 2 terms, you can just keep it this way. In the book, if you see a similar problem like this in the book, the answer will be kept this way. They won't try to change the minus 3 into plus 3. Okay, so this is definitely the final answer, no matter whether you're looking at my lecture video or the textbook. This is definitely the final answer. Okay, so that concludes section 9.5 on rationalizing the denominator. Again, remember the method you use for 2 terms, okay, is different than when you have just a single term in your denominator, which was from the first half of section 9.1 in a separate video that we did. Okay, just please keep that in mind when you study. Make sure you remember that difference and you know each method accordingly that goes with each different thing. Okay, whether it's a single term or 2 terms on the bottom. Okay? So you have a good day. We'll see you back here for section 9.7. Okay, we're not going to do 9.6 yet. We'll do it later, but not right now. So we'll see you back here in the next video for section 9.7. Again, you have a good day, and we'll see you then.